Hey guys, it's Bryce and Aaron with another Fusion update, and this is our first for 2017, and we're already starting with a ton of enhancements. Aaron, you're going to start us off this year. What do we got?
Well, we're going to kick it off right. We're going to kick it off with modeling. There's a ton of new enhancements, so let's take a look. January is bringing some amazing stuff to Fusion 360, and as we work along with this head trimmer design, we'll show you some of our favorite things. As I use the view cube to adjust the views and get accustomed to the device, you'll probably already notice that the global X, Y, and Z axes are now clearly visible here. This will help immensely because, as you know, directions can get pretty arbitrary pretty fast. With that, let's set out on our design task. And at this stage, we want to ensure the center of mass is located in such a way as to balance it as much as possible. The new center of mass callout should help with that. Once turned on from the inspect dropdown, we'll now visibly see where the center of mass is. Right now it's a little forward for my liking, so let's explore how we can improve the situation. Let's focus on the heaviest of items, the mechanical system. What I want to test here is how big a difference moving the motor back might affect the center of gravity location. Accessing the move command, you'll notice a handful of differences. We'll cover these as the video goes on, but for now, we'll select to move the component using a new move type, translate. While we've had the ability to translate from the move command, using this new option helps declutter the manipulators. In addition, I'll leverage another new option here, the toggle to capture the position. This adds a feature in the timeline, making later edits easier. As I click OK, turn your attention to the associative center of mass as it updates. As expected, it moves back, but not enough considering all the design changes a move like this would require. So we'll delete the capture position feature to return it from whence it came, and explore another change. The counterweight might have similar effects, and in looking at the handle, I see some prime real estate where we could add one. But to maximize the effects, let's move the ribs to accommodate a larger counterweight. I'll pre-select the faces and hit the M key on my keyboard to start the move command again. Because I pre-selected faces, it automatically takes me to one of my favorite new move features, Move Faces. This existed prior, but only when you weren't capturing design history. This new capability will allow me to easily move and rotate these two ribs to my liking, and the best part is that with history turned on, it captures the move in a feature so I can go back and edit it later. Because I don't want the weight to shift during use, I want to make sure it fits snugly against the oddly shaped walls. To ensure I replicate the walls, let's jump into the sculpt mode and convert these faces. The new convert dialog box feedback makes it clear what input Fusion is expecting. We'll jump ahead to the finished sculpted shape, and now I need to close off the ends and make a solid out of this. To jump to the patch workspace, I'll use the Control or Command bracket key to switch between workspaces. This keyboard shortcut will allow me to stay focused on what matters, my design, rather than digging through those menus. We'll patch both ends and stitch it together to make a solid. Then convert the body to a component. Let's see how effective this is to the center of mass. I'll suppress and unsuppress the counterweight and notice how this improves the balance of the device. If I'm now done with the center of mass, we can turn it off from the analysis folder. On the front of the hedge trimmer, it appears I'm missing a screw that attaches the blade sleeve to the body. To fix this, let's first measure the distance the new screw will need to be offset from the existing. As I access the measure command by hitting I on my keyboard, you'll see a new option here. It's related to the snap points, which will be off by default. Snap points are all these little guys you see on this face I'm about to select from. While these can be handy when you want them, when you don't want them, they can be quite annoying. Let's turn them off, then continue measuring the distance. 35mm is the offset, so let's use that now as we use the move/copy command. I was trying to glance past the new copy part of the tool when I used it earlier. Anyway, I'll select the existing screw, toggle the translate option once again, but this time I want to make sure to toggle on the create copy option before I key in the measured value. This is one of those times the global triad comes in handy. And although I've highlighted about 10 new options in the move copy command, I still haven't covered all of the new stuff. Check out the always incredible What's New blog by Kaching. You'll be glad you did. This is looking pretty good for now, but let's turn our attention to the handle shape to highlight some other new options. Here I have a model that demonstrates the shape we eventually settled on, because I want to explore some changes. Using Loft to make a shape like this is a great option. When I turn on the Loft, a notable option here is Chain Selection. New to this release is the fact that it will remember the options data as additional Loft features are added. This is significantly more important when you go to use a loft in the patch workspace, which again, I'll use the command brackets to switch to. The chain selection option here will, by default, be turned off. This is the more desirable option, as you typically use the patch environment to gain more control over individual faces or items. The next profile I'd like to use is one single entity, however. So let's adjust the sketch to give me more control. As I go to edit the sketch, I want you to note this, the sketch origin, which will always be visible. This is incredibly handy because without it, sketching even a line to intersect the shape would be difficult to locate. With the origin always visible, I can make the end coincident to the sketch origin and that line is properly positioned. These little things can sometimes result in huge improvements. Now, the patch loft can continue.
In this update, we have improved the viewing experience while in work offline mode. Now, while in offline mode, the project and folder structure remains consistent to the look and feel while in online mode. First, Fusion 360 has a period where it will cache files that have been opened locally. These are the files that can be opened while in offline mode. To control the time for this period, go to your name, then Preferences, then change the offline cache time period. Now, when you go offline, you will see the same project and folder structure as if you were online. The main difference is files that are cached locally and can be opened and edited while offline are going to be lit up. Files that are gray are not cached locally. You will have to wait to be back online to open these files. Don't worry, we will be improving the offline experience even further. Make sure to check out the Fusion forecast in the Fusion 360 blog to see what else is coming for work offline mode. Next, in the January update, we have several big enhancements to hit the rendering environment. First, let's open up the Appearance Library. Now, we can search the Appearance Library. This will search the Fusion 360 appearances, My Cloud appearances, and My Favorites. Speaking of cloud appearances, in this update, we now have cloud appearances. Simply modify any of the appearances in the project and select Copy to My Appearances. The list of My Appearances is sorted just like the Fusion 360 library and is searchable. Now you will be able to sign in to any machine using your Autodesk ID and access your appearances on any device. Not only did the Appearance Library see some big enhancements, but the in-canvas rendering also saw some major improvements. First, let's start the in-canvas renderer. And notice the bar at the bottom right corner that specifies the elapsed time and number of iterations. Let's open up the settings. There is a new lock view checkbox. Previously, if you accidentally panned, zoomed, or rotated while you were rendering in Canvas, it would reset. Now, we can save ourselves from screaming at the screen by locking the view. While the in-canvas render is on, Fusion 360 will not let you change the view. Notice that I'm rendering in fast mode. Let's go ahead and switch to advanced. Notice the bar at the bottom changes. Finally, the bar at the bottom has different quality settings for excellent, final, and infinite. Use the arrow to place on any of these or anything in between. The renderer will stop once it reaches the specified quality setting. Now, let's switch over to some of the nuggets to hit the CAM environment. First, we have added cloud assets. These assets will be stored in the cloud, which means no matter which computer you sign into Fusion 360 on, you will have access to these assets. Turn them on by going to the Preferences, CAM, and select Enable Cloud Libraries. Now there will be an Assets located in the Data panel. Currently, the assets support CAM templates, CAM tool libraries, and CAM posts. Let's start by adding some CAM tool libraries. I'll go ahead and start by opening up my CAM tool library. There are several ways to add to your assets. Tools that are stored in the cloud library will appear in the assets. One way to add is to import existing libraries into the cloud library. Notice after a refresh that the library is shown in the data panel. Another way is to create a new library in the cloud library, then add your favorite tools from other libraries into that folder. In addition, we can upload straight into the data panel using the upload button. Now let's switch over to CAM templates. Now when you create a CAM template, it will be stored in that assets folder. Simply select your favorite collection of toolpaths, right-click, and select Store as Template. Now, no matter what machine you are on, you can use your favorite CAM templates while you are programming your part. The CAM environment is the first place we will be seeing assets being used. But spoiler alert, stay tuned for future updates where maybe other environments take advantage of these cloud assets. Now let's switch gears to some probing. In this update, we can now probe the stock. In this example, we want to probe the center of the stock. Selecting off the model geometry would be difficult to locate the center. Instead, we could switch to Probe mode to stock. Now we can select on the yellow stock preview to probe the center of the stock. The probe type will change automatically based off of this selection. Next, let's create a new probe feature. This time we will use the model probe mode. Let's probe this middle surface. We are trying to locate the surface of this part, but if we machined out this center pocket already, the probe would have nothing to touch off. Instead, let's enable Use Selection Point. This will use the location where I clicked on the surface as the probing location. Now previously, when creating a drilling operation for several different holes, Fusion 360 has this awesome checkbox to optimize the order for the order of the holes that are being drilled. Well, in this update, we added this optimize order option to the thread, bore, and circular toolpath. Let's take a look at this bore toolpath. Just visually looking at this toolpath, I can see the toolpath crossing itself, which will increase the time and distance of the rapid. Now let's edit the toolpath and select the new Optimize Order option. Now we can see a much better order being used for this bore. Let's switch over to a lathe example. In this update, we now have a new turning secondary spindle chuck and return. This allows you to control the process of passing between the primary spindle and the secondary spindle on a lathe. Let's start by using the turning secondary spindle chuck. Here we get a feed plane, which is how far it's going to wrap it in. And then you get a chuck plane. I'm going to drag it over so it chucks around the thread, right here. Now the secondary spindle will come over and grab the part. Then we can use a parting operation. In the machine, the two spindles will be simultaneously spinning around the part, both holding the stock and the part. The parting operation comes in and cuts the stock off. Then we can use the secondary spindle return and send it back. Finally, we can finish up the backside of this part in the second setup with a facing operation and a groove. Last but not least, we have updated the HSM kernel, which is the backbone of the Fusion 360 CAM environment. Because of this, Fusion 360 toolpaths are more efficient where they start and end. For example, these two facing operations are the exact same, except for the second facing operation, we will enable both sides on the Passes tab. Now, if we watch the first simulation without the option enabled, we will see unnecessary rapid movements when the operation steps down the multiple depths. Now let's watch the simulation with both sides option enabled. Notice as the tool steps down, its lead in is in the same location as the lead out, saving time in rapiding. For this toolpath, this option decreased the machining time by 2 seconds from 48 seconds to 46 seconds. Imagine if we were machining thousands of these parts. We would save ourselves precious time. Time equals money, does it not?
Well, that's some great stuff you just showed us, Bryce. I absolutely love that you can search through appearances. That's going to save me a lot of time, but also the cloud assets, being able to access those from anywhere in the world. I mean, that's the beauty of these cloud tools.
Yeah, it's awesome. I have to say, though, my favorite enhancement is the XYZ on the ViewCube. Love that stuff.
Yeah.
But now we're going to show you some new technology called branching and merging. This is going to be really useful for those working in collaborative environments. Let's go ahead and check it out right now.
We've been talking branch and merge for some time now, so it's my pleasure to give you a first glance at its capabilities. Let's start with a dive into this by introducing some of the commands and show it in action. You can pretty much sum up all the commands you need to know from this one drop-down. Create branch, create milestone, pull, push, and view project history, which we'll select. When we do, we can see the path the hedge trimmer design took, and along the way the milestones, each designating major changes in the design for organizational purposes. At this point, we're ready to explore some new handle designs, but before we do so, we'll make a new milestone. This can be done from the dropdown as we showed earlier, but doing it from the project history adds some nice clarity. In addition, we'll create some branches from the history view as well. Each branch will allow for exploration of the handle shapes. An important note is that branching and merging in general is done from the project level, not the individual design level. Because Bryce is part of this project team, he'll get a notification as each branch gets created to ensure the member is privy of the latest developments. Before I start exploring this handle design, I'll first close the history window. And to begin work on what I see as the best design, the curve variation, I'll need to activate that branch. To do this, I'll select the project icon and the corresponding branch. Note the color that will not only be present here, but also in the design tabs in Fusion. On each user's computer, the icon will be consistent. And as we work away on these, it's evident that Bryce is working on the thick branch and I'm working on the curved branch. Being able to have multiple branches going at the same time, stemming from the same milestone, will come to a solution in no time. When the winner of this little design challenge is decided, we can look to merge the changes back to the master. The merge can be done in one of two ways, either pushing the changes or pulling the changes. But that mainly depends on what's active. That said, I'll opt to do this from the project history again, only because I find it to have more clarity. Currently, I'm active on the curve branch, made evident from the highlights in the tree, or the branch data below. On the top, I can see what models differ here from that of the master. If I click to change to the thick variation, I'll see the same, but only for this version of the design. It's been decided, however, that the curve variation is the one we want to move forward with, so we'll right-click on that milestone from the branch and select to push the changes from that branch to the master. From the next dialog, I'll select to merge the main assembly and the handle from the curve branch to that of the master. It's a good idea to add a summary and description for organizational purposes. And when it finishes, you can see the changes in the tree, and although the changes were moved from the curve branch, it still continues in case other downstream edits are needed. I'll open up the master branch main assembly, and the nice new handle is visible here. With branching and merging, you can explore design variations without consequence and manage changes like a pro. You can be sure we're building tons of learning content to support branch and merge. Until you're fully confident with this tool, I'd recommend you create a couple test projects to try it out on.
Man, branching and merging is going to open up some capabilities for team and collaboration environments. But I'd recommend opening up a project and doing some trial and error with it. It's going to take some getting used to, but it's going to open up a lot of capabilities in the long run.
Yeah, good call on that. Good to get to know it before you start implementing it in your day-to-day. Anyway, thanks for watching, everybody. We hope you enjoyed this update and everything else. Check out the quick tips, subscribe to the YouTube channel. Other than that, thanks for watching, and until next time.
Happy New Year's, guys.